right. It looks like we're right at the top of the hour, so we'll go ahead and get started. Firstly, I just wanted to welcome everyone to the webinar and thank you all so much for joining us today. We're really excited to have you here. My name is Kayla Ripple, and I'm a senior associate with the LenFest Ocean Program. So for those of you that don't know us, the LenFest Ocean Program is a grant-making program that funds ocean and coastal research projects and expert working groups to address the needs facing decision makers and stakeholders today. You can learn more about us and the projects we fund at lenfestocean.org. And while you're there, you can also sign up for our newsletter. And if you're on Twitter, be sure to follow us at lenfestocean. In fact, we'll also be live tweeting this webinar today using the hashtag LOPwebinar. So if you're a tweeter and want to engage with us there, feel free to use that hashtag LOPwebinar and engage with us there if you're so inclined. Today, we're very excited to have joining us Dr. Olaf Jensen and Dr. Rujia Bi with the University of Wisconsin. They'll be sharing details of a new project that started in September 2020 to identify stock assessments that may be vulnerable to climate change. This work is important because it could help managers prioritize fish and invertebrate populations that may be more susceptible to stock assessment failures in the future. This project is the outcome of an ideas lab that was hosted in 2019, where the LenFest Ocean Program, along with our partners, the David and Lucille Packard Foundation and the Biodiversity Funders Group, convened researchers, managers, and stakeholders in generating research priorities around fisheries management challenges associated with shifting marine species. The workshop was focused on the US East and West Coast and has since resulted in a series of projects that will advance understanding and contribute solutions to different aspects of the climate and fisheries puzzle. In the coming months, we'll be sharing each of these projects with you as part of our Species on the Move Ideas Lab webinar series. Our next webinar is actually on February 25th, and we'll share research being led by Dr. James Morley from East Carolina University. The focus of his project is to understand the role of habitat in life history in fisheries vulnerable to climate change. But the project we're here to share today is being led by Dr. Jensen and is the kickoff to our Species on the Move series. So I'll leave it to he and Dr. B to get into the details. But during the Ideas Lab, the importance of informing how stock assessments may be vulnerable to climate change was one theme that consistently came up. So this project will be important in addressing those needs. Not only is this webinar kicking off our Species on the Move series, but it's also something we like to call a launch webinar, which is meant to inform and engage audiences from the outset of a project rather than just at the end when a project has results. So this project is still in its early stages and there are many opportunities to engage with this work. So if you're interested, please do reach out to us at LenFest or to members on the research team. We'd love to hear from you. Now, before we get started, I just wanted to share a few webinar logistics with everyone. With so many people in attendance, we have all attendees muted to prevent any feedback or echoes. And there will be time at the end for questions. So please use the Q&A panel to type and submit your questions at any point during the webinar today. We'll be keeping track of those in the queue, and at the end of the webinar, I'll read it aloud for the researchers to answer. Now, depending on how many questions there are, we may not be able to get to them all, but folks are certainly welcome to follow up with us here at LenFest or with the research team afterwards. And finally, we are committed to making LenFest funded work transparent and easily accessible for all stakeholders. So we'll be recording this webinar and we'll distribute the link broadly afterwards. And feel free to share this link with others once you receive it. We'd be happy to spread the word out. Maybe there are some people who that wanted to join the webinar today but weren't able to make it. So please feel free to share that once you get it. And also, as this project goes on, we'll continue to share information on its progress via a variety of different avenues, like on our website, in our newsletter, on Twitter, and then on other places as they pop up and seem appropriate. But for now, I've started creating a running distribution list for everyone who's interested. If you're not on that or unsure if you are, just send me a note. You can find my email here on the slide in front of you. And lastly, after you close out of the webinar, you'll be taken to a very short 3-question survey. And if you could take a few minutes to fill that survey out, we'd be really grateful for any feedback you have and can provide. It's going to be extremely helpful for us to better understand the best way to engage with you and with others as we continue outreach around this project. And so I think that's everything. And with that, I'll go ahead and turn things over to Dr. Jensen. Olaf, I'm going to stop sharing my screen. And I'll go ahead and transfer presenter privileges over to you.
Okay, thanks.
And you should be able to share your screen now.
Great, how's that go?
That's good. There you go. Perfect.
Wonderful. Well, thank you very much, Kayla, for the introduction and for convening the webinar. And thank you to the folks who are attending here. I really appreciate your interest, and I hope this spawns some conversations. I know there's a lot of related work on this topic going on, and I would love to hear about other projects that touch on this subject. So I'm really excited to kick this off, in part because we have a really fantastic project team here. It's a mix of scientists at academic institutions, as well as those at fishery management institutions, and an illustrious advisory board keeping us on track and focused on the goal, which is to make this work relevant and useful for fishery managers who are facing some very tough decisions right now as a result of climate change. So I just want to start off with an analogy that I think is maybe useful for thinking about the role of stock assessment in fishery management. If you think of a fishery as a ship and the fishery managers as the captain, then I guess stock assessment could be something like the GPS, the device that tells you where you are. It doesn't tell you where you want to go. That's something you have to define for yourself, but it can tell you where you are relative to where you're hoping to go. But in another sense, that analogy is not quite apt, because a GPS will give you extremely precise updates on seconds to minutes scale of temporal frequency. And stock assessments, we're lucky to get them every 2 or 3 years. And when we do get them, they're of course coming with a lot of error. So I think stock assessments might be more appropriately compared to something like celestial navigation, where even in the hands of a skilled practitioner, a skilled stock assessment scientist, you still only get occasional and very approximate feedback about where the fishery is and where it's heading. And that challenge is made even worse as climate change is shifting some of the underlying biology and ecology of the stocks that we're trying to manage. So if we go back to basics and think of population biomass and changes in that biomass as just a function of births and deaths, immigration and emigration, and growth in the body, all of those processes are impacted by climate. We have good empirical evidence at this point that all of those processes are already being impacted by climate changes and ocean warming. The issue that comes up is that while in real life now with climate change, those processes are dynamic, in stock assessments, the parameters that represent them, things like the natural mortality rate or the stock recruitment relationships, those are typically treated as constant. They're typically fixed. And that's not because stock assessment scientists are naive or don't understand ecology or don't want to do things differently. It's because of some very fundamental challenges in trying to model non-stationary systems. That is, where the basic processes themselves are changing through time. And the impacts are not just limited to the biology. The observation process by which we observe changes in stock abundance is also being impacted by climate change. So things like range shifts altering the overlap between the fish populations that we're seeking to manage and the fishery independent survey footprints that are used as the basis for stock assessments. And I think it's worth highlighting this one for just a second here. Jason Link had a really nice example of this. When you've got shifting stocks moving through a stock boundary or the boundary of a survey footprint, the area of the stock here is the green, and the shifts are movements of those green dots. The actual stock size in this example is constant. It's not changing, but as it moves out of one survey footprint and into another, you can get apparent changes in stock size as a changing proportion of the total stock is being assessed by the fishery independent survey. And we know that this is happening for many different stocks right now, both stocks shifting poleward with ocean warming, but also stocks shifting deeper and off the outer edge of the fishery independent surveys. So climate impacts and stock assessment are not just a matter of biology, they're also a matter of changes in the observation process. And it gets even worse, of course, when you have not only shifts, but changes in the area occupied by the stocks, as we frequently do when stock size changes. So this is not just a theoretical problem for stock assessment. I'll give a little hint here that I think is at least suggestive that it may be already starting to undermine some of our assessment performance. And the location I'll look at here is New England. So and I think it's perhaps representative of what is likely to happen elsewhere as climate change continues. Andy Pershing had a really interesting paper showing that the Gulf of Maine has warmed faster than about 99% of the world's oceans. So if we're going to be seeing climate impacts on stock assessment, this is a good place to look. And indeed, when John Wiedemann and I went back and looked at the historical consistency of stock assessment advice, this is what we found, and this is a little bit difficult to interpret, but each point here is a year stock combination. And the upshot here is that stocks, points that fall above the dashed line are places where the fishery management advice failed. So the actual fishing mortality rate ended up being quite a bit higher than predicted. And cases to the right of the vertical dashed line are places where fishery managers failed to follow the advice. And what you can see is that in this case, the advice was followed fairly consistently. We've got relatively few examples to the right of the dashed line where the actual catches were just much higher than the recommended targets. Instead, what we have is many cases where the actual fishing mortality rates, as judged by future stock assessments, greatly exceeded those predicted for that level of harvest. So we have a fairly widespread failure of stock assessments to provide consistent advice for fishery managers. And again, that's not to fault the assessment scientists themselves. They're struggling with an incredibly difficult challenge here. Okay, and like I said, that's suggestive, but it's far from conclusive about the role of climate in stock assessment performance. There are, of course, many additional factors that influence that performance. If we have enough good data, you can probably model your way out of many of these changes. And by enough good data, I mean surveys that effectively capture the species, first of all. So our fishery independent surveys only adequately capture a small fraction of the species that we fish for. And then surveys that cover the entire stock distribution. We can't learn about shifts unless you have surveys that are truly synoptic and cover the entire distribution. And if you add something like annual age length keys, you could also keep track of changes in growth. This is sort of pie in the sky. There are very few assessments that have all of these pieces, and then also the model structures developed that can make use of these data. There's also characteristics of the fish species themselves, fish and invertebrate species, that can influence performance. Slow life histories are simply easier to predict in terms of their dynamics, at least in the short term, than fast life histories. If you want to know, for example, the abundance of ocean quahog next year, the abundance this year is a very good guide because they have extremely slow life histories and they're not changing in abundance very quickly, which makes for much more consistent stock assessments. So given these, and given that climate change is not just annual SST, the challenge for this project is to try to tease apart these various factors. So we're also thinking about climate change as temperature during critical life stages, changes in phenology, and then also primary production and food resources, which are likely to be the pathways by which ocean warming is actually altering the biology. Okay, I'm going to turn it over to Rujia in just a second here. The project goals are first to simply characterize stock assessment performance. And by performance here, I mean consistency between successive stock assessments. That's a somewhat watered down definition of performance. But what we're doing here is trying to take an empirical approach where we don't actually know the truth, right? If we knew the truth, we would the truth of the underlying dynamics of the stocks, we wouldn't be in this position to begin with. There are other projects tackling the same problem from a simulation approach where you do actually know the truth. And then after we've done that characterization, we're looking to explain variation in assessment performance as a function of climate and other environmental changes, as well as characteristics of the species and the assessment model. I expect we'll find some fairly complicated interactions among these factors. And then finally, where the rubber meets the road here, our final goal is to develop empirically grounded guidance for specifying buffers for scientific uncertainty that are informed by climate impacts on assessments. And I'll turn it over to Rujia Bi, who is a new postdoctoral research associate working on this, to talk a little bit more about how we're going about this research.
Okay. In the following, is it clear? Okay, in the following, I will give a brief presentation on the research approach and methods. Next, please. For the project timeline, we plan to assemble data in the first 6 months and analyze the accuracy of harvest advice from the past stock assessments by characterizing the consistency of stock assessment performance in the following 6 months, and then explain variation in assessment performance and investigate potential covariates. And finally, develop guidance for specifying buffers for scientific uncertainty and identify effective strategies to avoid overfishing. I will talk about the analysis and turn it over to Olaf for outreach activities. Next, please. This project will focus on stocks across the US, but is broadly applicable to all other regions. We will utilize the existing assessment data from the RAM Legacy Stock Assessment Database. This map shows the distribution of stocks included in the RAM Legacy database. Each stock is an error, country, and species triple. There are a total of more than 1,300 stocks included in the RAM Legacy database. Next, please. Briefly, as Olaf said, we don't know the truth. What we do is to compare the older assessment with the most recent one to check the consistency of stock assessment performance. We will compare outputs from the two most recent assessments of each stock, calculate differences in estimates of biomass and fishing mortality between these two assessments, because relative differences in these quantities are one measure of assessment failure. These figures are our preliminary results comparing the biomass and fishing mortality estimates in the same year from the two most recent assessments for each stock. The red lines are the one-to-one line. Many stocks have inconsistent estimates of biomass and fishing mortality for the two assessments. Next. So we incorporated some covariates, which will come from four broad categories. Environmental factors that may influence biological and observation components of the stock assessment model, such as sea surface temperature and climate indices. Stock assessment model and data characteristics that might take the assessment more or less robust, like a general model type, for example, age-aggregated model or age-structured model, and the presence and absence of time-varying parameters. The third category is biological sensitivity scores from climate vulnerability assessment, such as life history traits and some behaviors. And finally, a regional covariate that represents additional unobserved regional differences that are not captured by the other covariates. Next. We will show some details of sea surface temperature in the following. We pick black sea bass in the mid-Atlantic as an example, and show its stock boundary overplayed on the Kobe SST grade, which is highlighted by the red box. Next, please. This figure shows the SST trend for black sea bass in the mid-Atlantic. The period of the most recent assessment is marked by red. The SST displays an increased trend during this period. The blue line is the fitted Tilson slope. Next, please. So our first approach is to develop a generalized linear model, showing that the assessment error will be modeled as a function of climate and other characteristics covariates. We will also test for interactions among predictor variables. For example, it's likely that the biological sensitivity scores are only good predictors of stock assessment failure once environmental changes reach a certain level. Because such interactions are not only possible, but likely, we will also explore a more flexible modeling framework, such as boosted regression trees. Boosted regression trees are a type of machine learning approach that can more readily detect interaction among variables and threshold responses. The fitted model can then be used to predict the likely error in the current assessment outputs of biomass and fishing mortality. Okay, thank you, and I will turn it over to Olaf.
Thank you very much, Rujia. So I just want to wrap up here by talking about the application of these results to management, and I'll draw on an example from the Mid-Atlantic Fishery Management Council and the process for their scientific and statistical committee, because I'm a member of that committee. Every fishery management council in the U.S. does things a bit differently, and so this won't be directly applicable to all of them, but we're hoping to work with the different councils and their SSCs to understand where it might be useful. So the overall goal here is not to improve stock assessments, but to know when and how much to trust them. Improving stock assessments is obviously critical. Climate robust stock assessment development is an enormous area of research right now, and there's a lot of very smart people working on that. So thinking about where this knowledge fits into the process, assessment output in the US under the federal fishery management system goes to scientific and statistical committees which evaluate that assessment output and then provide advice to fishery management councils that takes into account the assessment outputs as well as their uncertainties and the risk preferences of the fishery management council. All of that is combined to provide advice about the overfishing limit and uncertainties in the overfishing limit. So just two definitions here. The overfishing limit is the best estimate of the maximum amount of a stock that can be captured in a year without resulting in overfishing. And the acceptable biological catch is the overfishing limit minus some buffer for scientific uncertainty. And for the Mid-Atlantic Council, the way this works is the council itself defines the acceptable risk of overfishing depending on the status of the stock and a few other factors. And that, of course, is a management decision. It's not a scientific decision about what is acceptable. But in the U.S. system, that is always less than 50%. And so based on that probability of overfishing that they're willing to accept, and the distribution of uncertainty around the overfishing limit, there is some buffer here between the ABC, the acceptable biological catch, and that overfishing limit in order to attempt to hit the probability of overfishing that the council has specified. And so it's these buffers here that I think are where this research might be most useful. At this point, defining the uncertainty around the OFL and thus defining the buffer is a process that could really use a lot more empirical support. It's done differently in different places. And in many cases, the buffer is a way of accounting for uncertainty in our knowledge without having the knowledge to know exactly how big that buffer should be. And these buffers are critically important, but they're also a constraint on the fishing industry as well, and on the economic performance of the fishing industry. So it's critically important that we don't simply arbitrarily increase the size of these buffers as a way of responding to climate change. That would come with enormous downsides in terms of the economic performance of fisheries. So the goal here is really to target those buffers and provide a strong scientific basis for defining them. Once we're at that stage, we're hoping to, as I say, take it on the road and work with different scientific and statistical committees to figure out how and whether this information could be incorporated into their process. Everyone does it differently, and we certainly don't expect that there'll be a one-size-fits-all solution. So I'll stop there because I'm very interested to hear questions from the audience, and if there's additional feedback, I would love to talk with you individually. Please do reach out. Thank you.
Awesome. Thank you, Olaf and Rujia. That was great. Olaf, I'm going to mute you again real quick and then take you off mute whenever we get to the question. Because I hear some
I'm sorry,
feedback.
Kayla?
I'm just hearing some feedback, so I'm going to mute you for a second and then just unmute yourself when we're ready for the question.
Sounds good.
Yep. All right, so thank you both for that presentation. That was extremely helpful. And as we're waiting for people to type in their questions, I'm just going to put up a slide with the research team again and their contact information if you'd like to reach out and get in touch with them about the project. Let me move this over. And it looks like we already have a couple of questions. So we'll just dive right into that. All right. So the first question is, how will you deal with retrospective bias in estimates from stock assessments?
Oh, good. I'm glad that that was asked. Retrospective bias, as is typically thought of, is looking at is done by doing peels, where we remove some data and look at how much the quantities of interest change as we remove the successive years of data. This is a little bit different here than that. We're looking at change between successive stock assessments. So not retrospective bias in the particular way that it's meant in terms of stock assessments, but a little bit different retrospective approach. I'll add that one of the things that we will test is whether those estimates, things like Mohn's Rho, those estimates of retrospective bias are good predictors of assessment uncertainty. In some work that John Wiedemann has led, he's found so far that they're not necessarily good predictors of assessment consistency.
Awesome, thank you. All right, and our next question, and just real quick, I will make sure that everyone knows the Q&A section is right on the right-hand side of your screen. So there should be a little panel underneath the chat box. If you type your question into the chat box, I'll try to get to that. But I'm monitoring that Q&A panel, so just make sure you put it in there to ensure that I see it and we can ask it to the speakers. So thanks everyone who has submitted their questions so far. All right, so the next question is, when comparing the most recent stock assessments, how did you account for the recalibrated MRIP estimates?
Great, thank you for that question, Jeff. So we've not yet done this work. We're just setting out, and I think data recalibrations are one of the ways that assessments are inconsistent. So if you have, as Jeff well knows, if you have changes in the underlying data that are going into the assessment, that adds to inconsistency. I just want to skip ahead there to Tom Miller's question, which is very related to that. It's about how you control for changes in assessment structure between successive assessments. I think changes in the underlying data and changes in the assessment structure are two ways that you end up with inconsistency in the assessment advice. And so I think the way we're going to address this is to simply use those changes as covariates in the analysis. So how frequently do you find the assessment estimates of parameters like biomass or fish and mortality rate or the OFL are changing because of changes to the assessment structure versus changes to the underlying data versus other factors. And I think it's likely that the frequency of changes in assessment structure and data will be higher in places where climate change is altering some of the underlying dynamics. So that I think there's going to be some fairly complex dependencies there among those factors.
Excellent. Thanks, Olaf. And then the next question is addressing how to reduce scientific uncertainty and buffers. So how do we reduce buffers for scientific uncertainty? More stock assessments?
Great. Yeah, that's a very good question. I think in the ultimate answer is improved and more frequent stock assessments. Stock assessments that can incorporate a lot of these variables that are now, a lot of these parameters that are now dynamic because of climate change. But that's not our goal here. Our goal here is to target the buffers for scientific uncertainty to those stocks where we think they're most needed, where the analysis shows that they're most needed. So it not necessarily reducing the buffers everywhere, but only including climate buffers for uncertainty for those stocks that are likely to be the most uncertain.
Thank you. That's great. So I think we're still waiting on a couple of questions to come in. So while we're waiting for those questions to come into that Q&A panel, I did want to point out to attendees that I've included a link to the project fact sheet that we have here, which is a really quick summary and two-pager of the project itself and the members of the research team. So that'll be a really good resource for you moving forward, just to learn a little bit more about the project and how to reach out and get in touch with the research team and with LenFest if you want to. All right, and we have another question coming in. Will the results of this work provide insight into which type, i.e. model, is vulnerable to climate change, or stocks that may be vulnerable? Whoops, I just lost it. Or stocks that may be vulnerable, or a combination of both?
Brandon, I'm hoping it will be a combination of the two, and very likely interactions between them, right? I mean, there are likely to be cases where stocks have biological characteristics that make them vulnerable, but if they have sufficient data and complex assessment structure that can deal with some of these time-varying parameters from climate change, then they can be robust. So all of the above. And I think the challenge obviously is sorting out those different influences.
Mm-hmm. How will you consider climate-induced changes in reference points?
Right, that's a good question. I think what we're going to do here is not look at changes in the underlying reference points, but look at changes in the assessment output. As I'm saying, and I'm realizing we'll probably also have to deal with the question of changing reference points. We simply haven't gotten to that stage yet. But what we do have in the database is the estimates of the stock biomass and fish and mortality rates are separate from the estimates of the reference points. So we should be able to separate out changes that come from uncertainty in estimates of biomass versus those that come from uncertainty in the reference points themselves.
Great. So we have a question regarding stakeholder engagement. So you mentioned traveling to different councils or SSCs. Do you also plan to communicate with stakeholders, especially as you prioritize stock assessments that may be vulnerable?
For sure, we do hope to communicate with stakeholders, and I think we will likely do that through the councils, and perhaps if the councils are willing, through the advisory bodies, the stakeholder advisory bodies to the different councils. In terms of prioritization, the approach we're taking here is to look at as many stock assessments as we can. The limit is only whether we have two different stock assessments of the same stock. So whenever we have that situation, we will be including those stocks in the analysis. that's both a strength and a weakness of the approach. It's designed to gather a lot of data and look at patterns across many different stocks, but it of course limits the amount of detail we can go into on any specific stock.
Mm-hmm. Excellent. Yeah, and I'll just add to that. Like I said, we have the fact sheet in there to talk a little bit more about the project and areas where stakeholders may get involved throughout. So please do reach out to us at LendFest or to Olaf or anyone on the research team, as you have questions or, would like to meet with us to talk more about this or discuss any comments or questions that you might have about the project itself.
That's right. Thank you for that, Kayla. And I would be particularly interested in hearing from stakeholder groups that were interested in having meetings to discuss some of these results. So if any of you were thinking about particular stakeholder groups that had an interest here, we're very open to meeting and talking about it.
Excellent. All right. I'm not seeing any more questions. So we'll just wait a few more minutes in case anyone has some questions that they're thinking of and want to put them in that Q&A. And if not, we can end early, and that gives everyone plenty of time to answer the really fast survey questions that we have at the end of the webinar that will help us figure out how to best engage with you as we move forward with this project. Okay, well, I'm not seeing any more questions come up on the screen. So with that, I will go ahead and we can close out the webinar. Thank you all for joining us. Special thanks to Olaf and Rujia for giving a great overview of this project as it's starting. We're really looking forward to seeing how it progresses over the next few years throughout the lifespan of the project. And like I mentioned earlier, please do take some time to fill out that survey at the end of the webinar. It's going to be really important for us and for the research team as we think about the best way to engage everyone. And with that, I will go ahead and close out the webinar. So thank you all for your time and for joining us.
Thank you very much.